The big difference between computers and people is that people have feelings and opinions and life outside of work.
Code is just documentation of requirements.
The system design is pretty clear. You gather the requirements, understand the patterns, the tactics you want to apply, and then design the system, right, and get it into production. However, like your message is that we don't need to design technical systems. We need to design something different, which is called social technical systems. Can you tell me what that is in particular?
The social structures in the organizations and technical artifacts are highly intertwined, and it is not that efficient if we would design the social ones and technical ones separately. So we have to design them somehow together. And this together is what I call socio-technical system. And socio-technical engineering is basically an idea to take classical systems engineering approach to a broader socio-technical systems. And that's it. Everything else is implementation details.
Okay, so you're saying we need to design organizations in the similar manner as we design software systems.
Yes, but I'm fully aware that we can't design non-deterministic systems like we design deterministic ones, but we can design conditions under which socio-technical systems can grow in a way we would them like to grow.
Okay, what are the examples of those conditions? What they are?
It's basically policies based on requirements we need. For example, if we have, let's say, requirement, we want socio-technical scalability, like classical scalability for the technical system. Socio-technical scalability would mean for me, we want to be able to grow our organization and get more throughput, more performance.
Okay.
Because usually we just ramp up the team, it gets slower, technical and a social way. And by making these requirements as a policy, we can think about the technical decisions we have to make to enable the scalability, and we have to think about social decisions we have to make for achieving the scalability.
Uh, this sounds slightly strange to me because this is kind of a new approach that you give the requirements to the organization itself. Because, like in a typical business cycle, it happens like this: there's a new year, uh, like financial year, let's say, coming, and you have some kind of a goals that you set for yourself for your organization. And the goals are like enter a new market or increase the revenue by 30% or something like that. So it's not like a requirements that we want the system to be scalable. It's about goals like we want to grow the revenue 30%. How does those goals can be translated into the requirements to the organization?
Okay. For me, those goals that you set, this are kind of the highest level of requirements that the organization has. And like with system design, we have systems, product requirements, and so on, then system design requirements, component requirements, and so on. So these goals are the highest possible level. And from those goals, it's like with OKR, we are trying to yeah to break them down into the design how we want to achieve them. And maybe we will figure out that in order to attain this goal, we have to create product X. And that probably we will not be on time, or maybe we will. So we are a little bit uncertain. So we want to prepare our socio-technical system for scalability so that we get an opportunity in order to attain this business goal, ramp down the team. And if we have requirements like this, it is very transparent. We can communicate it to the technical architects and saying, okay, guys, we need this feature. Don't optimize for the today's social architecture. Optimize it for scalability. It will certainly has a cost, but if you don't have this transparent requirement, I suppose technical architects will never address it because it is in general case you have to pay for something that you don't need.
Uh, the gap between those annual goals and the technical architects in the teams, for example, is pretty wide. How do you communicate this? How do you translate these goals into the things that can be said as a goal for technical architects?
Okay, well, architects are working with requirements, right?
Mm-hmm.
So whatever the goals are, they have to be somehow converted to requirements for them. Usually they get technical requirements. My point is that they just get more requirements on
Okay.
the table that have social aspects. And also that social architects like organization designers, so basically even project leads and so on, that they get input from technical side their requirements, because I assume that these things like availability of the social technical system, scalability, they have social and technical parts to it, and those people have to sit together to see how to fulfill these requirements in action.
Do you want to know how to design proper software systems? Do you want to grow to a senior or staff engineer positions? I developed a business oriented system design course specifically to achieve those goals. We're gonna learn how to identify and gather the requirements and also prioritize them, how to address performance, security, reliability requirements, how to document software architectures, and how to make architecture decisions. The course consists of 10 lectures, 10 home tasks, and the final work. You're gonna receive the graduation certificates by the end of the course. All the details by the links below the video.
Who should be doing this? I mean, in an engineering organization, you will find like engineers, you will find architects, you will find engineering managers, you will find, I don't know, somebody else. Like, who should be responsible for this social technical part?
Well, I would say the project lead or software development lead, whoever is the lead of the organization,
Mm-hmm.
should be the socio-technical engineer responsible for the socio-technical requirements. And she could work together with a socio-technical architect or with social lead and technical lead to see how these requirements can be achieved. But
So,
the ultimate task of the project lead would be to get these requirements and prioritize them.
so in a similar manner as product managers and engineering managers are working together to define the product that should be built, the same way like senior managers and like architects should work together to shape the form of the organization.
Exactly, yeah. And I'm I'm not proposing to do something differently.
Mm-hmm.
I'm just proposing to make things transparent, which usually are in the heads of single individuals. Like bringing these things to the table. Oh, we need the scalability, or we need availability of certain roles. This
Mm-hmm.
makes these things transparent, and it enables discussions about social technical designs, because it prevents people making absolute decisions like, oh, I prefer, I don't know, AWS, or I prefer microservice architecture because it was better. So it's this kind of absolute decisions without relating to requirements. And once you bring requirements to the table, you're enabling constructive discussion among social and technical people.
Oh yeah, that's always the case when people are just proposing some solution because they used to work with them, and
Mhm.
then it appears that it doesn't fit the task anyway. So and you start this ramble about like, hey, it doesn't fit here. Why did you choose this in the first place, and so on and so on.
Mhm.
Okay, so you told a lot about roles, architects, artifacts, and so on. So I know that you talk a lot about like role architect mapping, role artifact mapping. So can
Mhm.
you elaborate on this?
Okay. I was so the basic idea of the entire approach is to use systems engineering for social technical systems. And if you want to use it, we need some language to describe social technical systems. And for me, the language consists of elements of social technical systems and decisions to arrange those elements, like in a classical systems engineering. And I see three categories of elements in social technical systems. The first one is people. Second one are artifacts. And by artifacts, I don't only mean code, components, or system design, or so on. I mean basically every artifact an organization creates, like requirements documentation, test cases, maybe even project handbook. So every artifact that is required from the project to be delivered. And then, given that definition, roles for me are responsibilities for artifacts. For example, lead software architect is just someone who is responsible for software architecture documentation. It's not someone who makes decisions or oversees an architecture process. It is implementation details for me. So the role is basically someone who is responsible for software architecture documentation. It doesn't matter how it gets created. And we can deploy roles onto instances, and instances are people. So, for example, we have deployed the role of software architect to just one person, and if this person is on vacation, people would say, "Oh, we don't have software architect our because she or he is on vacation." But in my terminology, I would say in this case, the service software architect has downtime, and so the service is not available. And given this terminology, we can start discussing, okay, do we need do we need an availability of this role all the time? Do we want to deploy it onto two instances, like having some redundancy in the system for the sake of availability? And if the lead socio-technical engineer decides that the availability is more important than efficiency of one instance, then one can deploy this role onto two instances and bearing the cost of this decision, meaning that two of them will not be as efficient as if they would be working alone. They have to sync, have something common knowledge base, maybe attending all the meetings all together. So redundancy has price.
And
And
they will need to use the consensus protocol as well. So you will deploy Paxos on both people.
yeah, exactly. Yeah. So, and having these requirements makes these kinds of decisions transparent and helps arguing something. For example, if someone is very efficient and try to withhold information just to be efficient and work independently, one can say, okay, because you are a very efficient guy, thank you, but because of your efficiency, we have low availability of your role in the system. If you're on vacation or if you're sick, we can't make decisions without you. Availability is more important for us than your efficiency, so we have now two architects.
Okay,
Something.
so it sounds like you're approaching this designing of the project team the same way as software. So you basically say, hey, like instead of services that are giving us the payload, we'll have people, but they basically do the service too, and we can measure the same attributes like downtime, availability, performance, right? So you can measure basically, I don't know, like the amount of decisions an architect made, or amount of lines produced by a developer, and so on.
If it's needed, for sure, yeah.
Yeah, and then apply basically the same tactics. So if you're talking about availability tactics, doesn't matter if it's like a virtual machine or a person, you're just basically applying redundancy and load balancing anyway. So
Exactly. This is what I'm speaking about in my talk, that we can get catalogs of common tactics to achieve certain kind of requirement like availability, scalability, and reuse those tactics in socio-technical context, like bring in some redundancy into the system to achieve availability.
okay, but I think the big difference between computers and people is that people have feelings and opinions and life outside of work. So
Exactly.
how do you account for this difference?
Mhm. So basically, what you are saying is that because people are individuals that have different opinions, maybe different needs, this creates political arena. So we need to address this political issues, that there are maybe conflicts of interests, and so I would say we have to reduce somehow the political aspects of decisions making to avoid conflicts. And introducing requirements is very helpful because it makes argumentations more transparent. For example, if there are, so to say, if you have an organization with lots of .NET developers,
Mhm.
and then someone comes and say, okay, we want to make our next application in Node.js, which basically disadvantages all the old stuff, right? So there is immediately a conflict of interest. And if there is not a high-level socio-technical requirement that explains this, it will always be facing some insurgency from,
Okay.
from the old guard, so to say. And yeah, exactly. What I want to say is that socio-technical requirements for me is an instrument to reduce this political weight that affects organizations mostly negatively. But by
Do you
helping,
yeah,
yeah,
do you say that you can just introduce a goal or a requirement and say, hey, we want to achieve this, and then you can force a decision on people that they still don't like?
well, the difference is if we don't have requirements like this, then everyone makes decisions in isolation because they like it, and that's it. And they just don't converge to each other. If we introduce a requirement as a draft, at least, we can initiate a discussion and let different sides to express their opinion and so on. And at the end, the lead socio-technical engineer should take decision, prioritize, and in this case, she would need to explain her decision to all sides involved. But this would be clear communication why we go this way and not another one. So it will have more chances to get people on board with this decision.
Okay, so it's like a way how to explain and get a buy-in from people about certain decisions.
Yeah, exactly.
Okay, got it. In your talk, you also talk about this residual uncertainty. What's
Mhm.
that? It?
Okay. So I see the work of an architect is to prevent changes that involve lots of effort. And so that's basically why we have software architects. If we don't have any changes or no uncertainty, we would just design the system in a complicated domain and not in a complex one. This would be just straightforward system design. I see the work of an architect as someone who prevents shit from happening. And this uncertainty that architects are facing, I call it residual uncertainty. We don't want to reduce all uncertainty. We just trying to navigate this residual uncertainty. It may come from uncertainty of requirements. It may come from uncertainty in financing. It may come from uncertainty in the scope, in the timeline, from whatever it comes. It could be also technical uncertainty. We don't know if the system with this architecture will run. So we have to build like POC to verify technical feasibility. So, and all this is for me technical. For me, it's a residual uncertainty.
Okay, so I'm trying to understand that it's not perfectly clear to me. So
Okay,
uncertainty is basically anything that you don't know for sure. Is that correct?
exactly. Yes.
But I mean, it's the common situation. Like it's always you don't understand something or know something because like there are, first of all, there are known unknowns. Second,
Mhm.
there are like things that you like known unknowns, things like you're not certain about something. So how does this like lack of knowledge or understanding make it special, make it a separate system property?
I wouldn't say it makes it special. I would say it's a business as usual in dealing with uncertainty
Hmm.
in the realm of socio-technical systems. As you said, there are known unknowns. They are sort of easy. Basically, architects do some kind of encapsulation to encapsulate this possible point of change where they known unknowns.
Hmm.
Of course, they can never protect against unknown unknowns because they don't know, but there are surely tactics to explore unknown unknowns just by delivering something quickly and see what happens at any stage of software development. It must not be implementing code and see how it runs in production. In many contexts, like medical devices or aviation, code is not the first artifact you have to care about.
Yeah,
It's
yeah, yeah.
basically code is just documentation of requirements. But you have to deliver your requirements, specifications, see how they are reviewed and so on. Maybe
Okay.
get approval from authorities and so on.
Okay. Speaking back to this known unknowns, so how do you handle them as architects? You just make assumptions, right? So you don't know that you know that you don't know about like particular aspects, like for example how payments are done in your system, and then you just assume something like, hey, we accept only credit cards. But how an architect should approach these unknown unknowns, something that they cannot make assumptions about?
Mhm. I think the half of the answer for me would be just doing nothing because we don't know. But given the assumption that there are some unknowns, I said we have to undertake some steps just to explore this area that we don't see, just shooting in the sky and see what we mark, so to say.
How it works in practice? Do you have any stories about that?
Yeah, basically deliver something what is not ready, whatever it is, architecture diagram, code, specification, and just to get earlier feedback. That's it. So everything is about getting feedback as early as possible, but not only technical feedback, but also social technical one.
Uh, Can you elaborate on this? Like for the technical feedback, I can
Mhm.
understand like, hey, this thing is too slow, right? Or
Yeah.
this is not very usable. So it's pretty clear. What is the feedback in the social technical perspective?
Okay. Um, well, for example, if you architect in medical devices project, yeah,
Hmm.
your most important artifact is software architecture documentation that should first of all address safety and security risks. This entire cloud and microservices stuff, it's your second problem, yeah.
Hmm.
Uh, and you know that the lead time for your verification of your design, which is software architecture document, is very long because audits will be maybe requested in 1 or 2 years from external authorities. But what you can do is already trying to get your review done by hiring external experts that will make your review earlier than external authorities before you
Hmm.
start developing the system. So basically trying to get people that can provide you feedback as early as possible.
Okay, so the earlier feedback is kind of key to discover. So
Unknown
it's
unknowns.
yeah, so it's basically exploration, right?
Yeah, yeah.
So you're just going out there with a torchlight and trying to find all the dark places which you
Yeah.
can stumble upon later and figure out. Okay, this is the problem. We need to get back, prepare, and attack the problem again.
Hmm. Yeah.
Okay.
Um, what I've seen once, I'm not sure if it was a good decision or bad one, but the argumentation of the client was we are hiring one service provider that has 2,000 engineers in East Europe. We don't know if we will need all of them or many of them. We just want to have a partner that can scale.
Mm-hmm.
We are sure that they have not an experience that our internal staff has because they are new and are not business domain experts. We just buy them for their opportunity to scale. So this is the way they address this unknown situation. So they don't yet know if they will need this scale, but they are already buying this, having some redundancy, having total inefficiency.
Mm-hmm.
They're buying this hedging of the risks.
Okay. Okay. All right. So it's basically you again have a trade-off of efficiency versus cost. And if cost is not of a problem for you, no, it's not efficiency versus cost. It's like cost versus missed opportunity, probably.
I think it's efficiency versus scalability.
Okay.
Yeah, and scalability is translated to costs.
Yeah. So it's like you will spend more resources right now, but at the appropriate time, you will be able to ramp up a lot of people very quickly, so you can build a better, more products. Okay.
Yeah, and you don't even know if you will need it or not.
Okay. I bet there are clauses in the contract that they can get rid of it like very fast.
Yeah, yeah.
Okay, it's basically the same as what happens in the big companies when they hire, and then they
Mhm.
understand they don't need a lot of people anymore, and they just fire them en masse.
Yeah. Yeah, they're trying to keep some core internally and
Mhm.
then have this scalability as externals.
Okay. Do you have any like interesting stories about like people trying to build a social technical systems and failing miserably?
Um, Actually, I would say every project has a social technical architecture,
Hmm.
like every software system has software architecture. Uh, but some of them are built by people intentionally, but most of them are accidental architectures. So I would say every software development organization that has failed to achieve their goals has failed in socio-technical, in their accidental socio-technical architecture. Basically, or mostly because they just didn't do it. It just evolved somehow.
Okay. So your take is that you probably didn't fail the system design. You failed the social technical design. So you build up wrong organization for your problem.
Yeah. So in my experience, all projects that failed, and I would say for most projects that failed in my experience, hope not because of me, but but I would say at the end they failed because of technical debts that were just accumulating, and the project just died because of it. But I would never say that the project has died because of the technical debt. It has died because of a political environment that
Hmm.
let this debt grow. And I assume it is correct for the most of the cases where the problems are the politics. And we need to need to find ways to address this political arena and
Hmm.
help to uncover conflicts there.
But this is one of the most challenging thing for engineers, I believe, to navigate these political games, right? Because computers are relatively easy. You study the math, you study programming languages, you study tactics of software architecture, you go and study the guarantees that the components provide, and you build it up all together. And then if something goes wrong, you just stop it for a minute, debug it, fix it, problem
Mhm.
solved. However, like the navigating this organizational structure and making changes and pursuing people to build the appropriate structure, this is kind of unknown to engineers at all. How one can learn such skills?
Um, yes. So that's why I'm trying to use systems engineering that engineers are already aware of into these socio-technical systems. So the classical lingo that people like we speak applied one level higher. And having requirements is always better for the politics. It is even better for the architects, just on the technical area. If we don't have clear requirements, and every architect would take decision based on their experience, and they're always biased. Having the requirements, we open a space for discussion, seeing how different solutions are fulfilling or not fulfilling these requirements. And the same will be true on the next political level.
Okay, so imagine I'm an architect and like I'm all good with the technical requirements for my
Yes.
system,
Mhm.
but there's a like stubborn business owner who thinks it should be done completely different. What the steps you should take? Like what kind of conversations you should have?
Okay. I would say if there are conflicts in the interest, we should find a common ground by finding out which goals we want to achieve. Like the next goals that understandable for both for us. Like if we're saying our concern wants to grow for in 10% next year, this is nothing what we both of us can understand. Something what both of us can understand. So somehow referring our discussion to a social technical requirement. If you don't have any, we should sit together and try to find out and define this requirement. And after we have defined it, and assuming either one of us can prioritize this or someone we have to ask someone else to get prioritization of this requirement. Let's say some when we will get a green light to attain this requirement, then we can discuss which of our solutions is better for fulfilling this requirement.
All right. So alignment on common goals basically helps.
Exactly, yeah. And then
Okay.
writing time requirements and like for systems engineer, if new requirement is being added, you have to run through the list of other requirements, see if there are conflicts, maybe prioritize them again, maybe prioritize new one, then informing systems architect that the requirements have changed. So maybe the architect has to change the system, social
Mhm.
technical one, and so on. So the classical patterns of systems engineering applied to software technical systems.
Okay. In technical systems, we have such things as like architecture fitness functions, right? So some kind of a test that allow you to understand if you fulfill any of the technical requirements. Are there any analogies of these fitness functions in social technical systems?
Okay, and in the talk about social technical engineering, I make an example of using Gherkin style for testing social technical systems based on the requirement for availability. Let's say we have a requirement that in our software organization we want to be able to make any architectural decision at any time, which basically means that we shouldn't have just one software architect.
Hmm.
And we can basically write a test case that says, given John Doe is a software architect, when John Doe is on vacation and software architecture audit is being requested, then this audit should not result in any major findings. So this is kind of Gherkin style test case, and we
Hmm.
can run it. We can basically wait until John Doe is on vacation, or we send him to vacation, and then we request an audit. So where the lead architect is not there, and see what happens. So either the test is green, then everything okay, and the test might be green because we have two or three architects, or because John Doe was so good at his job that he put everything he had in his head into some artifacts available for everyone, then the test will be green. If John Doe was withholding some information or making some decisions unilaterally, then the test will be red, so we can react.
Okay. And we can come up with a set of those tests and run them periodically.
I'm not sure if we can we can find out analogies for all kinds of requirements. For example, if we have some functional requirement, we need to finalize this project within 2 years. So we can basically our project is a test case for itself.
Okay.
At the end of 2 years, we will see if we have fulfilled this test or not.
Okay. Engineering managers and like directors of engineering, they frequently work with stuff like engagement of personnel, the overall satisfaction, growth opportunities, and so on and so on. So what they should know about like social technical systems to be able to improve these goals for their organizations.
Mhm. Okay, so first of all, I would put the staff satisfaction as a socio-technical requirement. If it
Hmm.
is a requirement, maybe we don't need satisfied people. Maybe we just want to create some prototype very fast to achieve our business goals. So we don't need happy developers, maybe.
Okay.
but but
But in, but in the long run, you kind of need.
yeah. But if we have a situation where we need some happy developers because we have long-term products, so to say, I would just put socio-technical requirements that our engineers should be happy or satisfied, whatever it means. At least this requirement, it opens the space for discussion and for the further specification with developers and architects and everyone involved, how this requirement can be translated. And maybe from this requirement, we will derive, okay, we need somehow make our system more distributed, even if a monolithic solution or even more, if more coupled solution would be better from the technical point of view. But based on this requirement, could make sense to make the system more distributed and make single persons or groups of persons responsible for single components just to achieve their intrinsic need for autonomy and mastery and so on. So in that case, we would overrule technical performance for the social one, if this requirement is, again, prioritized higher than other ones.
So speaking about the prioritization of requirements, so what are the tools out there to prioritize the requirements, given that we gathered both like social, technical, and technical ones?
I would not differentiate between social technical requirements and technical ones. One can use the same tools, Jira, I don't know, HP, ILM, and other tools that everyone hates.
Okay, what we used to use for this requirements prioritization are utility trees. So you basically line up all the requirements, then you estimate the architecture impact and business impact, and then you basically pick up everything which is high or high medium. So there are the most important ones, and prioritize for them, and everything else is like you just approach them as you can.
It's good. I didn't know about this. I like the idea.
Okay, yeah, architecture tree is basically fun. It's like a tree of those requirements where you have those requirements grouped by an area. Like for the performance, you can have throughput, you can have latency, you can have like anything else. Or for scalability, you can have, or like for disaster recovery, you can have RTO or RPO and other goals and so on.
Oh, okay.
So yeah,
Cool. Architecture tree, right?
yeah. Well, utility tree. It's called
Utility tree. Okay.
utility tree.
Okay, I have to Google it. Thank you. Yeah,
uh,
but you're right. If you have some requirement like if we get a new person on board, we want that this person is able to, to become operational within the first cup of coffee being still warm. So means that person is getting immediately on track. And this requirement would actually mean that we have to meet a lot of technical decisions. And for example, using C++ as a programming language will not be one of them.
yeah.
Because it just disables this requirement. It will never be fulfilled. And if we are, for example, in the context where we are developing fighter jet, where C++ and similar programming languages are almost the only option, then we will say this requirement is on your tree, is on this lower lower priority quadrant.
Yeah, indeed. Yeah, because you have other priorities.
Yeah.
All right, all right. Do I have any other questions written down here? So, what tools do you use to have this like role artifact mapping there? Is it like just common diagramming, or there are any special software for this?
Just common diagramming, draw.io, and so on.
Okay, how do you manage the like when you make the decisions? You obviously change those diagrams because you change the organizations and roles and so on and so on. How do you keep the history of those changes, and how do you see how your system evolves?
Okay, I have to admit I don't have any experience with this kind of having this diagram as a project artifact where we are talking together, making decisions, because I never had an authority to come and say, okay, I'm a social technical engineer, we will do this. What I mostly try to do is to make kind of bottom-up social technical engineering, where in the cases where there are some conflicting requirements in the projects or just different conflicts of interest, that we try to reverse engineer this tree from the from the current team setup, so to say, just to navigate those requirements. But I've never had this roles and artifacts mapping really used in production as a tool to navigate software technical requirements, because I always lacked the authority to do so.
Okay. What was the most complex project you participated in to build up this or change social technical system?
It was a project in Germany where I would say we had very bad technology, state of technology, because of very bad political environment, where third-party service providers were hired under conditions that would create those conflicts. For example, where the client would create a contract and letting third-party service providers compete for this product contract, which makes making commitments that they can't deliver. And then, because if they don't commit, they don't get the contract. So they would cut corners where possible just to make this commitment possible. And this is a game that everyone loses, because at the end it's just technical debts that accumulate. And in this situation, the techniques was not a problem. It was politics that creates this environment vulnerable to technical debt situation. And in this environment, what happens is intransparency of decisions, because the third-party providers have a need to keep the narrative in their favor. So whatever happens, they have an advantage if they can interpret it in a way that they were doing always everything right, and if something was faulty, that's because someone else did it. So it's not because they're intrinsically bad; it's because the situation them to behave like this.
Okay.
And
So did you change anything?
yes, what I tried to do is to make things more transparent. So I offered my help in documenting decisions, architecture decisions. So everything's something what everyone hates. But after I documented previous decisions, it helped to establish a culture that, okay, when we make a decision, we have to document it. And for the future decision, it also means that we have to sit together and discuss it, not making it intransparently on someone's side. And this trick helped to bring transparency in the project and make the decisions more structured, communicate better. Okay, it didn't save the world, but it made it a little bit better place. So
Okay.
this is the socio-technical trick to address this political situation.
Got it. I don't have any more questions prepared. So I would just ask, like, what do you want to wish to our listeners, to our architects who is following this podcast?
So we are already at the end of the year, so I wish I could at least wish Merry Christmas and Happy New Year or other winter holidays.
Okay.
Yeah, if talking about socio-technical engineering, I could only wish to bring socio-technical requirements on the table, at least to address political arena in the organization. How to implement them as an architect, I would say implementation details. But
Okay.
having requirements is the most important step.
Yeah. Great. Thank you very much. Thank you all. Leave us a comment if you agree or disagree with this approach of building the organizations like technical systems. And see you next time.
Thanks, Vladimir.